All right, so in this video, I wanted to go ahead and go over a new set of functions called the exponential functions. Just like in our previous units, transformations also apply here. So I want you to be really thinking about how we shift right, left, which is describing the horizontal shift, up and down, describing the vertical shifts. Think about reflections. All that will apply here with this new type of function. So here in this worksheet, what they want you to do is graph this function, f of x equals 5 raised to the x power. Notice here that in our exponent, now it contains a variable x. So we'll graph that on Desmos and see how that looks. So on Desmos, I'll type in y equals 5 raised to the x power. And if you look at the graph, it gives you this shape right here. And what they want you to do is sketch it on this graph right here that they give you. So what's nice about Desmos is you can generate a table for this function. There's a little settings icons right here. If you click on the table option, that'll generate a couple points for you to focus in on. And if you look at this graph right here, we extend from -2 all the way to 2, which is exactly what our Desmos graph is showing. But here, most importantly, we hit the graph at 0, 1. So we can plot that out. That's approximately about right here. Then we then go to 1, 5. And at 2, we're at about 25. Okay. If we go to the left, to -1. We're at about 0.2, so about right there. And then at -2, we're really close to the x-axis, but not quite, but really close. We're about right there, approximately. So if we sketch this graph, it should look something like this right here. And it continues to go all the way up. Okay. But one thing I want to emphasize here in the graph, if you look at Desmos, if you keep on going all the way to the left, you sort of glide towards the x-axis. You never really touch it. So that is a very important concept here. This is a concept we did talk about when we graphed rational functions, and we'll point this out right now. But here, if you look at this first question, it asks you, where does the graph cross the y-axis? Well, here you want to focus in on the y-intercept. Here we cross the y-axis at 0, 1. That is our y-intercept. So we cross the y-axis at 0, 1. This is known as our y-intercept. For what values of x does this function use? This is hinting at domain. So what is the domain of this function? If you look at this graph right here, the sketch, the graph will go all the way to the left towards -infinity. And it'll also extend all the way to the right towards +infinity on the x-axis. So our domain here would be all real numbers or -infinity to +infinity. Okay. Next question, very similar. What values of y does the function use? This is hinting at the range of the function. Here you got to be just a bit more careful. But if you look at the graph, we never extend below the x-axis. So our y values are restricted. There's some type of barrier here that's restricting us from going down. You can also verify that on the graph on Desmos here to the right. So here, our y values can only be greater than 0. They can only be positive in this case. Anything above a y value, 0. And if you look at part D, this is something we mentioned a while ago. Do you think the graph will touch the x-axis? If you keep on looking at the graph here and going all the way to the left, it'll sort of glide towards the x-axis. It'll approach it, but never really touch it. So here, we'll say no. So therefore, this is directly related to the rational functions unit. We have an asymptote present. Okay. So here on this graph, specifically, we'll have a horizontal asymptote. So I'm labeling that on the graph. We'll have a horizontal asymptote. And to describe this horizontal line, it'll be at y equals 0. Okay. So these are the different characteristics I want you to keep in mind when we're walking through this worksheet. Y-intercept is very important. The presence of that asymptote is also very important. All right, so let's look at the next part in this worksheet. Here, they want you to do a very similar thing, but now they give you two other functions to graph. So here, we'll graph these three functions and list out these characteristics that we just mentioned. And what you really want to do is generalize any patterns that you see from these characteristics. So the first one we'll graph is y equals 2 to the x. We can generate a table here, list out a couple points that could be helpful for us when graphing. Okay, so here, for this one right here, y equals 2 to the x, we still cross at 0, 1. At 1, we're at 2. At 2, we're at 4. I can keep on going a little bit. At 3, we're 8. And let's see where we're at 4. At 4, we're at 16, but that totally goes off the graph. You can go a little bit to the left. At -1, we're about 0.5. Let's do one more. -2, we're at 1/4. 0.25. And we know that ultimately it'll approach the x-axis in this specific graph. And as you go all the way to the right, it'll continue to go all the way up. Okay. All right. So here the y-intercept is still located at 0, 1. The domain here will be all real numbers. The range is very similar to the previous one, is y is greater than 0. And the asymptote here is very, very similar. You still have that asymptote at y equals 0 here for this specific graph. Okay. All right. We'll graph the next one. Y equals 3 raised to the x power. We'll generate a table from that. All right. So here, look at the x. Our y-intercept is still at 0, 1. At 1, now we're at 3, so that changes. At 2, we're now at 9. If we continue to go to the right, it will still go all the way up outside the graph. Let's go a little bit more to the left. At -1, we're about at 0.333, so about right here. And -2, we're really, really close to the x-axis. So for the curve in red, that is representing y equals 3 to the x. And I want to make one thing clear here. We're still not touching the x-axis there. It'll get really, really close to it, but never fully touch it. But here for this one, the y-intercept is still at 0, 1. Domain is still the same, all real numbers. Range is still the same, y is greater than 0. And the asymptote is also the same as the previous one at y equals 0. But one thing I want you to notice is that the curve in red, y equals 3 to the x, appears to grow much more faster than compared to the one in blue, y equals 2 to the x. So just keep that in mind. And the last one is y equals, I'm going to put a parentheses around this right here. Okay. 1 divided by 2. close the parentheses, all raised to the x power. And if you notice here, the shape does definitely look different for this one. Okay. So I'm going to generate a table once again. List out a couple points. So the y-intercept is still at 0, 1 for this graph right here. For y equals 1/2 raised to the x. At 1, we're about 0.5. At 2, we're about 1/4. If I go to the left, at -1, we're at 2. At -2, we're at 4. Let's try -3. And at -3, we're at 8. So this graph now is decreasing as you go from left to right, but it's still approaching the x-axis. So here, once again, the y-intercept is still at 0, 1. Domain is still going to be all real numbers. It goes all the way to the left and to the right. Your range would still be y is greater than 0, because it's still above the x-axis. And the asymptote will actually be the same exact thing, y equals 0. Okay. All right. So if you notice here, all these share the same exact patterns. All three of these functions share. They all share the same y-intercept, domain, range, and horizontal asymptote. Okay. But one thing I just want you to think about here is that for these first two, these are increasing from left to right, as you can see here. And this last one is decreasing. For increasing, we'll label that as growth. And for decreasing, we'll label that as decay. Okay. All right, so let's go ahead and go to the back of this worksheet. Once again, here, they give you a list of 3 different functions to work with. And now they want you to see what type of patterns occur for these specific functions right here. But we'll start out with the same function here, y equals 2 to the x. We already graphed that, but we'll graph it again. If you generate the table, once again, here the y-intercept is going to be at 0, 1 for this one. 1, 2, 2, 4. Okay. And we know that at the end of the day, the graph will look something like this. Okay. The y-intercept here is still at 0, 1. Domain is still all real numbers. The range is y is greater than 0, because once again, it's above the x-axis. And the asymptote is the same thing, y equals 0. It's still present right here. So now let's grab the next one. Now they put a 3 in front of this exponential, and we'll see how that changes the graph. Okay. Let me generate a table. All right, so now the y-intercept, if you look at the y-intercept for this middle one, it's now at 0, 3. So maybe this number can affect where the y-intercept could be located. So think about that. But here we're at 0, 3. Let's plot a couple points. At 1, we're at 6. At 2, we're about 12. At -1, we're about 1.5-ish. And at -2, we're at 0.75-ish. So we know that the graph for that middle one looks something like this. And it'll still approach the x-axis. So the domain here will still be the same. It'll be all real numbers. It's still above the x-axis. So the y value would be still greater than 0 for the range. And the asymptote is still exactly the same, y equals 0. All right, let's go over to the next function right here. Y equals 1/2 parentheses 2 raised to the x power. We'll generate a table from that. All right, and now if you look at this one, this last one, our y-intercept is actually located at 0, half. So about right here. At 1, we're at 1. At 2, we're at 2. If we go to the left, this graph, this last one looks something like this. So notice here, our y-intercept is what changed throughout this whole process. Here it's at 0, 0.5, or you can label that as 1/2. Domain is still the same, all real numbers. Range is still above the x-axis, so y is greater than 0. And the asymptote is still exactly the same for all these three. So y equals 0. Okay. All right. So here, what do we notice? We notice that the y-intercept changed. So if we were to generalize this, if we started off with y equals some number raised to the x power, which is describing this type of function right here that we're looking at, if we attach some number in the front of this a value will represent the y-intercept. Okay. So that is one thing I want you to keep in mind when doing these problems. All right, and the last part of the video, last section, let's graph these last three functions and see what happens. So y equals 2 raised to the x plus 1. And let's see what happens. So at 0, for this first function, we're at 2. At 1, we're at 3. At 2, we're about 5. We can keep on going. At 3, we're about 9. If we go to the left, the graph should look something like this. Okay. And if you look at the graph, if you go all the way to the left, it sort of plateaus at 1. Okay, so be real careful with that. It doesn't go all the way down to the x-axis in this case. So it looks something like this. And it sort of appears that the asymptote is what shifted. So here we sort of have an asymptote. Not at y equals 0, but at y equals 1. So be careful with that. But here the y-intercept is going to be at 0, 2. Domain is still the same, all real numbers. The range, based on the asymptote, will be different in this case. Our asymptote is located at y equals 1. We can also confirm that on Desmos. If I type y equals 1, it sort of glides towards this horizontal asymptote. Never touches it, but glides towards it. So therefore, the range would be any y value above the asymptote, above the horizontal asymptote. All right, so we'll do the same thing for the next one. 2 raised to the x minus 3. If I graph that, we'll get a couple points. Now our y-intercept has changed. It's at 0, negative 2 for this one right here. At 1, we're at negative 1. At 2, we're at 1. At 3, we're about 5. If you go to the left, at -1, we're at -2.5. At -2, we're at -2.75. And if you look at the graph, it sort of plateaus towards -3. So here graphically at y equals -3, we have our HA, our horizontal asymptote for this one. So I'll just fill this graph in. It'll look something like this. And we can also label the asymptote here now. It's at y equals -3. So for the domain for this one, it's still all real numbers. The range here is based on the asymptote. Our asymptote now is shifted to y equals -3. And our range is any y value greater than -3. So notice here, our asymptote for both are coming from these last numbers at the end. +1, -3. That is causing that shift in the horizontal asymptote location. All right, and the last one. Let's grab that and see what happens. 2 raised to the, be real careful here. I'll put a parentheses and then type in x minus 1 because that whole thing is in the exponent. I will generate the table and let's see how this looks. Okay. So our y-intercept for this one is at 0, 1/2 according to the graph. 0, 1/2 is about right here. At 1, we're at 1. At 2, we're at 2. Let's see, we're at 3. At 3, we're about 4. If you go to the left at -1, we're at 0.25. Let's see. Even smaller. And the -2 are really, really close. Okay. So here, this graph looks something like this in green. All right, so the domain for the one in green is still all real numbers. The range here is based on the asymptote. Here, the asymptote is going back to y equals 0. So here, based on that, our range would be anything greater than 0. Or y values can be anything greater than 0. And what I want you to notice from this one, right here, this last one, is that it shifted our point, our original point, which is a 0, 1, to the right by 1. So here I want you to be thinking about transformations. If you are located on the inside, you always go opposite. So here I want you to think opposite sign. So this shifted 1 unit to the right, graphically. Okay. So here, most important thing, the range in the horizontal asymptote changed with a vertical shift present. So that number on the outside is our vertical shift. The y-intercept also changed as well. So just keep those ideas in mind. And lastly, let's go ahead and just generalize transformations for these types of functions. So here, the x minus h is the horizontal shift. Please be thinking opposite. H is opposite. K right here is our vertical shift. up or down. Keep the sign. And this a value right here represents our y-intercept. Only if there is no shift in the graph. Okay. So depending upon whether you have a horizontal shift or a vertical shift, that could affect the y-intercept. But if none of these are present, if none of the horizontal shift or the vertical shifts are present, whatever value is in front of here is the y-intercept. So just keep those ideas in mind. And lastly here, the domain for these functions will always be all real numbers. The range will depend upon where the asymptote is located. So here we'll say y is greater than wherever the asymptote is located. So here what we notice is that that k value represents the vertical shift. That'll determine the location of the horizontal asymptote. So here y is greater than k, and then our asymptote will be located at y equals whatever this vertical shift is, y equals k. And once again, this will inform you about where the range is located. All right, and last thing I want you to keep in mind, reflections. Those are also present in this graph. Okay. So if I gave you f of x equals negative 2 raised to the x, if the negative is on the outside, this will cause a reflection across the x-axis. So graphically, we know 2 raised to the x power will look something like this. But because we got that negative side in front, it'll reflect this function across the x-axis. So this function, negative 2 raised to the x, will look something like this. And the last reflection I want you to keep in mind, and I'll write it over here, is going to be f of x equals 2 to the negative x. So now the negative sign is in the inside. We talked about this idea as well when we were dealing with square roots. If your negative is on the inside, we'll have a reflection across the y-axis. So be careful with this one. So graphically, 2 raised to the x, once again, looks something like this. But here, because we have a negative on the inside, we'll reflect this across the y-axis. So this graph will look something like this. Go the other way around. Okay. So these are the different types of transformations I want you to be thinking about for these types of functions. Once again, these are ideas we talked about throughout the year, but these are the transformations I want you to focus in on for the exponential function. As always, if you have any questions, please let me know. I'm always happy to help out. Have a great day.